multiplication counting principle tells you. It says if you have this many of this event, you have this many of this event, and you have this many of this event, then simply multiply the number together, and that's how many total events you have. Okay? That's the multiplication counting principle. Okay? All right, going back to simple interest and compound interest. And these formulas are also in your little handouts and stuff. All right. The last thing under general mathematics is the basic binomial distribution. Okay, a little bit of probability. All right. And guys, from what I've been looking at, it does look like it's just the basic stuff. It's not, stuff that's really crazy. I think I have a couple problems here I'm going to let you guys try. And by the way, if any of you want this PowerPoint before we leave, if you've got a thumb drive, I can put it on there for you. All right, let's talk about permutations and combinations for just a minute. Remember, permutation means arrangement. Combination means grouping. Okay? So look at this first one. 5 books are in a row on a shelf. In how many ways can the books be arranged? Would that be a permutation or a combination? Permutation. What word gave that away? Arrange. Arrange means we got to put it in order. Okay? Permutation lets us know that. So if we have 5 books in a row, how many ways? Does anybody know?
120.
How many in a row? How many ways? How many choices do you have for that first book? 5. Okay. After you place one book, then you have 4. Then, okay. And then according to multiplication counting principle, we multiply them all together and we get 120. Okay. Another way we can do that is called 5 factorial. Okay. All right. I tell my kids that's 5 factorial, not 5! In English, that would be. Okay. So this literally means 5 times 4 times 3 times 2 times 1, right? It's 120. Okay. Now, if we write it as a permutation, okay, on your little TI calculators, you type in that, wouldn't you? Yeah. Okay. So we get 120, any of those ways. Okay? All right. 12 books are in a box. You wish to read 3 at a time. In how many ways can 3 books be taken from the box? Does order matter? No. So that gives you a hint that it's a combination. Okay, has anybody got a calculator? No. Oh my gosh.
I didn't know we were required.
It's okay. It's quite all right. Okay? But since this is a combination, that's how we type it in our calculator. Okay? And what we end up doing is the formula. Right? Okay? So 12 times 11 times 10 times, I'm not going to keep going. You know why I'm not going to keep going? Because those 9 factorials can cancel out. Exactly. So we can do this by hand, even if we don't have a calculator. You can't see it? Oh. All right. This one doesn't look like it's much better. Can y'all see that a little bit better now? All right, so what I have up here is 12 times 11 times 10 times 9 factorial. And I stopped at 9 factorial here. And that's because the 9 factorials can cancel. So see, even if you don't have a calculator, you could do this real quickly. What's 3 times 2 times 1? 6. So I can't cancel that out with that. All right, you can do 11 times 10 in your head. What's 11 times 10? 110. 110 times 2? 220. Okay, so see, we did that without a calculator. Aren't we brilliant? Of course. Okay. So it does help. It does help to know your formulas. I'll let your coach figure those out for you. Okay? All right. Now, probability likely events and binomial distribution, okay? All right, look at this with me. Suppose a fair coin. Why do you think they call it a fair coin? It's got to be heads and tails. It can't be two heads. It can't be weighted on one side. Okay? Suppose a fair coin is flipped 5 times. What's the probability it will land on heads at least 4 times? These are the types of questions you're going to be asked. A pro baseball player has a batting average of 367. What's the probability that during his next 7 at-bats that he will get it hit exactly 2 times? Okay? Do you want to try either one of those? Sure? Which one do you want to? I tell you what, this half the room, try the flipping the coin problem. Let's see what you get. This half the room, at least set it up for me. Since you don't have a calculator, you don't have to do it. This half of the room, try the batting average one. We'll see what you come up with. Give you about 5 minutes on it. Oh my gosh, I hate this stuff. Okay, when it says at least 4 heads, if we're flipping it 5 times, that means we want 4 or 5 heads, right? Okay, so we're going to do these separately. Let's do the probability of 4 heads first. Okay? It's going to be 5C4. Okay? The probability of flipping a head is 0.5, right? How many of those do we want? How many heads? 4 of them. That means we want 1 tails, right? Now, I'm showing you this way for a reason. I know there's another way to work it. Okay? But I'm showing you this way for a reason. All right? 5C4. Do that on your calculator, you get 5. Okay? 1/2 to the 4th power. You may know what that is? 1/16. Okay? 1/2 to the 1st power is 1/2. So our answer is 5/32. Okay? Now the reason I set this problem up this way is because if these two numbers aren't the same, okay, we can actually still work it with this same format. This is how I teach my kids to work it. Okay? Alright, looking at the pro baseball player, if his batting average is 367, guys, help us out here. What does that mean? What does 367 mean? .367. He gets a hit 36.7% of the time. Okay? So what that really means is the probability that he'll get a hit is .367. The probability of no hit then is 1 minus that, isn't it? 0.633. All right? And we want to get a hit exactly how many times? 2 times, right? So out of his 7 at-bats, we want to hit twice. So we're not going to set it up quite like this because we have nothing to add. We want exactly 2 times. All right? So 0.367